Ei, tropa, beleza? Eu tô com tipo, eu tava mexendo aqui no PC. Chegou uma notificação aqui pra mim. Não sei se vocês já viram, mas já vai se inscrevendo, deixando um like. Olha aqui. Compartilhando um vídeo. Quem viu isso? Quem viu isso, tropa?
Like the amount of gas that you budget yourself, destination address, amount of ether that you send,
Quem viu
data.
isso, tropa?
So if you're just sending ether, you don't need to care about data. If you're talking to a contract,
Puizinho, tropa.
then data
10
is
milhões.
readable by contract code. So data is how you specify what function of a contract you're calling, what parameters you're calling it with, anything sort of more complex with that. And VRS, elliptic curve digital signatures. Feel free to research them yourself. I think elliptic curve
O que
math is
esses caras
cool.
tá querendo com o Puizinho, tropa?
Receipts, not gonna bother with
O que ele
those.
quer com o Puizinho, velho?
Memory, storage, environment variables. So contracts have access to things like the timestamp, and this is great because you can have contracts that say if the time is greater than, something like January 1st, 2018, then do something. And there's lots of wonderful use cases for this. Logs, calling contracts, calling other contracts. Now, in general, if you're a contract writer, you're not going to be writing in like Ethereum virtual machine code directly. You're going to be writing in higher level languages, so Solidity is the most well-supported one right now. You can also write code in Serpent. There's also something called...
Tá batalhado aí, mano. Aí os caras chegam aí querendo já metendo um louco. Ranquei o canal do Pio. Ranquei o canal do Pio. Aí é chato, né, velho? O cara começou desde o começo, mano. Desde o começo. Desde o começo.
If, I actually wants to call some contracts and if I wants to register a domain name, then how am I going to do that? Well, over in the Serpent example, you might notice that I might want to do something like call the set IP function with some particular address and with some particular IP address. So the way that you actually do a call is by sending a transaction. The way that you specify what you're calling is in transaction data, and there exists this nice standardized algorithm.
Não tem nada, literalmente, apagou. Vamos ver o que tá escrito ali.
Encode the data. So the first 4 bytes represent the function ID, then 32 bytes for the first argument, then 32 bytes for the second argument. If you have variable sized arguments, it gets more complex, but feel free to research this.
Tudo.
So we have a new mining algorithm, and this mining algorithm strives to be kind of memory hard and GPU friendly. So the goal is to sort of prevent ASICs or prevent specialized hardware from like being the dominant force in mining, because that would make mining too centralized. But at the same time, CPU mining has other issues, so we have this sort of GPU mining that's a nice middle ground. It's a fairly pretty algorithm once again. It's called ETH hash. So fast block times, Merkle trees. So this is also a kind of very important piece of the Ethereum protocol. So the reason why I have this picture here is because about a year ago there was this cover in the New York Times that basically you have Life Masters that's saying it's all about the blockchain. And personally, I think it's not just about the blockchain, it's about the Merkle tree, and I think Merkle trees are like awesome and really important. So we should have Ralph Merkle saying it's all about the Merkle tree, and you should have some doges because doges are cool.
Então, mano, já era, Pio. Pô, tipo, é chato, velho. Os vídeos era mó legal, mano. Mas esses filha da mãe aí vem aí, ranqueia seu canal. Pô, isso que graça que ele tá dando risada.
So, Merkle trees, the point basically is, so this is how the Ethereum Lite client works. So the problem is, okay, if you have the entire database, if you have the entire state, if you have all the transactions, then you can know, let's say, what your account balance is, what some particular contract's code is, what some particular contract storage is, what some particular log says. But what if you're a light client? What if you're on a phone? What if you're on an IoT device and you don't have enough resources to process the entire blockchain? So the blockchain itself right now, the blockchain is 3 bytes. The sort of state size is something around between like 5 and 20 bytes depending on which client options you use. So it gets pretty big for a phone. So if, let's say, you have a tiny device that has like 50 megabytes and very low processing power, then what do? So this wonderful fellow came up with this algorithm where basically what you do is you store this kind of really clever hash tree where you store the pieces of data at the bottom, then you like have hashes of those, and you have hashes of hashes and hashes of hashes. And the end result is, if, let's say, all that I care about is getting key for, let's say, some like this particular key of, this particular account 175, then you don't actually have to download the entire blockchain yourself. Instead, all you do is you download this, what we call kind of this Merkle branch. You verify that the hashes inside of the branch are consistent, and as long as you have the block headers, you just kind of verify the Merkle branch against the block headers. And what you're doing is you're essentially allowing the miners to kind of help you verify that this particular piece of the state actually is what the node says it is. So if a node gives you this sort of Merkle proof that says this particular key, this particular account is 45, if you can verify the proof of work and you can verify the hashes, then basically you can verify that unless like all the miners are somewhere at that particular time conspiring to screw you over, this actually is what the state of the blockchain is in this particular place at that time. So the light client, there was like a test of an alpha version that was released a couple of weeks ago. I've tried it, it works great. So block headers contain 3 trees. So Bitcoin uses Merkle trees just for transactions. We use Merkle trees for transactions for the state. So this includes account balances, contract code, contract storage, receipts. So we have Patricia trees, which allow you to kind of update the tree very efficiently. And so those are kind of the basic building blocks of the Ethereum protocol right now. There's also very fun stuff that we're working on in the future, so things like proof of stake and scalability that I'm going to talk about in my presentation later today. Privacy support. So basically, with privacy, you don't have to actually build things into the base protocol. Because the Ethereum protocol is Turing complete, you can basically like implement any kind of advanced cryptography on top of it. Now, for like VM efficiency reasons, there are still sort of protocol tweaks that we have to make, but even still, it's something where like the vast majority of the work actually does sort of happen on the higher levels. Virtual machine upgrades, sort of more flexible use of storage and scalability, and these things are great. And just to set a good example, I'm going to stop now because the clock tells me to stop now. So thank you. Check. Oh, this one? Okay, let me try this. What's happening to it? It's just coming slowly. How do I go back? Oh, up. Yes. Okay, great, thank you. So I heard people in the audience complaining on WeChat about the mic being too quiet, so I'm going to try to keep it closer to my mouth this time around. We'll see if it works. Great, so this is one of the sort of standard presentations I give when people want just like a quick overview of the entire Ethereum protocol. So chances are you'll listen through this, you'll catch some things, you won't catch other things, but at the very least you'll kind of understand what the broad structure is, and if there's any particular piece that you don't fully understand, we have quite a few materials online that tell you about the rest. So we have our GitHub wiki, the website. If you are a developer, you can even read things like the yellow paper and the Ethereum source code. If you want to get like that deep an understanding of sort of how the Ethereum protocol works, I highly recommend doing those things. If you have specific questions, I also highly recommend even going into some of our public channels. So if you go to like gitter.im, gitter.im/Ethereum, for example, you can actually like literally just talk to our developers, and they're like right there, and you can ask questions. We're generally a fairly friendly community, I hope. So anyway, Ethereum in 25 minutes. So first of all, how did the project start? So project started back in 2013. At the time, people were very interested in blockchains. People were looking at Bitcoin. People were excited about Bitcoin. But people were also realizing that blockchains are useful for things other than just money. So back in 2011, there was a project called Namecoin, which was trying to make a blockchain-based domain name system. In 2013, there were projects called Colored Coins, which were trying to digitize arbitrary digital assets or arbitrary assets and put them on the blockchain.
Pô,
There were protocols
acabaram,
called
mano.
Mastercoin that were trying to integrate all sorts of really
Literalmente.
complex features.
Tipo,
So
só se ele criar
there's a
canal novo.
consensus that you can do lots of different really cool things with Bitcoin, or with other blockchains. Asset issuance, crowdfunding, title registration, lots and lots of stuff. Problem is, most blockchain protocols were designed like this. Pocket calculator, single-purpose device, works reasonably well for all you care about is adding and multiplying numbers, but it does nothing else. And sure, someone with an advanced computer science degree with a good calculator can kind of hack it to play a video game inside of it, but do you really want to do that? So, after this, in 2013, there were people who were making protocols that looked like this. So, Swiss Army knife. Basically, you come up with a list of 10 or 20 features he wants to have, make a little tiny thing for each one of them, stick them together into a knife, and there you go, that's your product. Or in this case, that's your blockchain. So back at the end of 2013, there were lots of projects that looked like this. They just said, okay, we want blockchains to be usable for asset issuance, crowdfunding, bets, prediction markets,